Good morning. Enter into the third unit, that is array antennas. Okay. What is the need of array antennas? Okay, array means, as you have stated in C language, array means group of similar elements arranged together. So before going to that, why should we go for array antennas? Okay. So for example, by using a single antenna, I am getting only 2 dB. The gain is 2 dB. But the customer asked for 10 dB. Customer asked for 10 dB. Okay. So you have possibility only to design an antenna with 2 dB. So how to get 10 dB means, if you want to increase the gain of an antenna, if you want to increase the gain or directivity of an antenna, compulsorily you want to go for array antennas. So that is the fundamental goal for going for antenna arrays. To increase the directivity, we are going for antenna arrays. We are going for antenna arrays. Okay. So let us discuss what are the different. Okay. So antenna array is defined as the radiating element formed by arranging various individual antennas in properly spaced and phased. Properly spaced and so if you observe in this diagram, this is one antenna, this is one antenna, this is one antenna. All the antennas, the separation distance between these two antennas, the separation between these two antennas, the separation between these two antennas are same. They are arranged in they are properly spaced, and the excitation, the power given to this antenna, the power given to this antenna, all the antennas. Okay, the supply given to this are in a phased manner. Okay, so generally an antenna array can be defined as system of similar elements directed to get high directivity, in the desired direction. So that is the major definition of antenna array. The major definition of antenna array is antenna array can be defined as system of similar elements. System of similar elements directed to get required high directivity in the desired direction. So this is the definition of antenna. This is the definition of antenna array. Okay. So similarly, when you say that the antenna array is linear, so an antenna array is said to be linear if all the elements mean here elements means nothing but antennas. If all the elements of the array are equally spaced. For example, this is one antenna, this is another antenna, this is third antenna, this is fourth antenna, this is fifth antenna, this is 1, 2, 3, 4, 5. If the separation distance between all these antennas is d, separation distance is d. If all antennas are separated equally by a distance d, then such type of antenna is called as linear array. So what is the definition of a linear array antenna? An antenna array is said to be linear if all the elements of an antenna array are equally spaced along the straight line. Equally spaced along the straight line is called as linear array. So similarly, when you say that the linear array as uniform linear array, and you say that the antenna array as uniform linear array, and you say that the array antenna as uniform linear array. And linear antenna is said to be uniform linear array. Uniform linear array if all the elements are fed with all. If all the elements here, elements means antennas. If all the elements are fed with currents of equal magnitudes with the progressive phase shift. With the progressive uniform phase shift. With progressive uniform phase shift along the line. So these are the different definitions for antenna array. Antenna array means can be defined as system of similar elements directed to get required high directivity in the desired direction. What is when you say that the array antenna is linear, if all the elements of an array are separated with the same distance, are separated by same distance, then we'll call that array as linear array. When we'll call it as a uniform array, if all the elements are fed with currents of equal magnitude and with progressive uniform phase shift along the line, then we say that the array is uniform array antenna. Okay, so see here. This is nothing but what are the elements? All the individual antennas, we call it as elements. All the individual antennas. This is one element, this is one element, this is one element, this is one element. So all these individual elements, are called as antennas. Okay. So arranging multiple antennas as an array to form a single system is the common method to combine to form a single data. So whatever all the systems will provide a single gain. Okay. So all the powers or all the radiation, all the gains will get collected and will get a single one. So it is to be noticed that antennas in an array must be properly spaced and in proper phase so that independent contribution of each antenna in the configuration in the same direction get added up, while it gets cancelled out in rest of all directions. Okay. So for improving the directivity, what is the main purpose of the antenna array? The main purpose of the antenna is for improving the directivity. The main purpose is to improve the directivity. We are going for antennas array. Okay, so these are the advantages. It offer high directivity. The main advantage of the antenna array, it provides the high directivity, strength will be more and less signal to noise ratio. The design of the antenna supports the antenna parameters. Coming to the disadvantage, due to the large number of antennas, the structure of an antenna is large. Okay, so they need large space. The bulkness of the antenna array makes it maintenance somewhat difficult, and resistive losses, since so many antennas are there, resistive losses will be there. So what are the applications of antennas? Wherever there is a need of high gain, more gain or directivity, compulsorily whenever the field strength should be more, okay, then we'll go for antenna array. Generally, it is used for satellite and wireless communications along with military and radar applications. Okay, so this is the brief introduction regarding antenna arrays. Okay, now let us discuss the classification of antenna arrays. Very, very important question. So this is very, very important question. Classification or types of antennas. There are 4 types of antennas array. The first one is broadside array, second one is end-fire array, and the third one is collinear array, and the fourth one is parasitic array. So total how many types of antennas arrays are there? 4 types. Okay, we'll discuss one by one. Let us come to the first one. What is the first one? First one is broadside. So broadside array. Okay. So what is meant by this broadside array? Okay. So see here in this, for example, here this is one antenna. This is one antenna. This is another antenna. This is the antenna. So totally 5 antennas are there. I have placed all this antenna on the separation distance between all the antennas is T. Separation distance between all the antennas is T. Okay. So here what is this one? This is nothing but antenna axis or array axis. Okay. So this line, this is nothing but array axis. Okay. So the type of arrangement of multiple identifiers that are placed parallel along the line or to the antenna axis form this type of arrangement. Okay, is known as antenna broadside array. So this is the most general used, the practical used configurations of broadside array and end-fire array. Okay, so if you make arrangement like this and if all the elements are fed with all the elements are fed with equal magnitude. If all the current, all the elements are fed with the equal currents, equal magnitudes of currents, and same phase, and same phase, then we will get the radiation, maximum radiation. This is the maximum radiation, which is perpendicular to the axis of array. So this is our axis of array. How is your maximum radiation? The maximum radiation is perpendicular to the axis of array. So if the maximum radiation is perpendicular to the, if the maximum radiation is perpendicular to the axis of array, the maximum radiation is perpendicular to the axis of array, then if the maximum radius is perpendicular to the axis of array, such type of arrangement is called as a broadside. Such type of arrangement is called as broadside array. Okay, how will you get this? How will you uh, how will you get this? How will you get this type of arrangement? This type of arrangement is how the maximum radiation will be perpendicular to the axis of. This is only possible if all the antennas or all the elements are fed with amplitude of current or magnitude of currents are equal, and the phase is also same. The phase is same. Amplitudes are same, amplitudes or magnitudes are same, and if phase is same, automatically the maximum radiation. So this is our axis of array, and maximum radiation will be like this, perpendicular to the axis of array, perpendicular to the axis of array. Okay. So this type of arrangement are placed equally. So they are providing bidirectional vector. They are providing bidirectional radiation. Okay. So next, that is regarding broadside array. This is regarding broadside array. Now come to the second type, second classification. This is second classification. And the second one, end fire array. Okay. So end fire array means the only difference is here. Let us consider these are the elements of the current elements. So here, what is the axis of array? This is my axis of array. This is my axis of array. This is my axis of array. In this, the maximum radiation will be along the axis of array. This, the maximum radiation will be along the axis of array. If the maximum radiation is along the axis of array, the maximum radiation is along the axis of array, then such type of antenna array is called as end fire. Generally, the maximum radiation is around 0 degrees or 180 degrees, 0 degrees. Whereas in broadside array, the maximum direction is, for example, 0 degrees. The maximum radiation is around 90 degrees and 270 degrees. In broadside array, maximum radiation is around 90 degrees and 270 degrees. Whereas in the end fire array, the maximum radiation is around 0 degrees. Okay. So see here, these are all the and this is one antenna, second antenna, third antenna, fourth antenna. Here, this is the antenna fact. In which direction the maximum radiation? Maximum radiation is also in same direction along the axis. Okay, so if you observe here, this is your axis of array. In which direction the maximum radiation? The maximum radiation is also in the same direction. The maximum radiation is also in the same direction. So this type of arrangement is called as end fire array. How will you achieve this? In the previous case, for getting the radiation perpendicular to the axis of array, we have provided all the current elements with the equal magnitude and same phase. How will you get this? Okay, so this whole element identical excited by currents of equal magnitude. So see here, here the currents are equal magnitude, but there is continuous variation in phase along the line in order to have unidirectional radiation pattern. So here, what is the major difference between that one and this one? So see here, in the previous case, 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 in end fire array, all have similar arrangement of the broadside. The crucial difference is lies in the way of excitation. In the end fire array, the elements are fed out of phase generally 180 degrees phase shift. Okay, whereas in broadside array, all the elements are fed with currents of same phase. This is the only difference. Okay, the previous case they are fed with progressive phase shift. Okay, but in end-fire array, they are fed with the progressive. The phase shift is different. Okay, so thus you can achieve end-fire array offers a unidirectional radiation pattern when the maximum radiation is achieved along the axis of Earth. Okay, so now we'll discuss the third one. The third one. What is this third one? Collinear antenna array. Collinear antenna. So the name itself indicates that is the arrangement that allows the placement of various antenna elements in a single line from end to other. So this is one element. Up to now, we have seen this type of arrangement. So now we have seen this type of arrangement, and this is axis of array. Now the elements in collinear array, all the antennas are placed like this, one after the other, one after the other. Okay, so here this is the axis of array. This is axis of array. Okay, if the arrangement is made like this, here also the maximum radiation will be perpendicular to the axis of array. Okay, the maximum radiation will be perpendicular to the axis of array. So this is on the third type, that is collinear array. This is collinear array. The same thing, we can place this antenna elements either in horizontal. Here we have kept this elements in horizontal. The same thing we can kept in vertical also. So this is first antenna. Next, this is the second antenna. Next, this is third antenna, like this. So this is our axis of array. Since our axis of array, here also the maximum radiation will be perpendicular to the axis of array, which is equal to the broadside. Okay, so here the orientation I have kept in horizontal. Here the antennas are kept in vertical. Here the antennas are kept in vertical. Okay, so this is similar to the broadside array, where the maximum radiation is perpendicular to the axis of array. Where the maximum radiation is perpendicular to the axis of array. Okay, so this is the third one. This is the third one. Okay. So next one, fourth one. Now let us come to the fourth one. Okay, so parasitic array. The fourth one is parasitic array. So what is meant by this parasitic array? In order to overcome the feeding problem, of the antenna, sometimes the elements of the array are fed through radiation from nearby element. The array of antennas in which the parasitic elements gets the power through electromagnetic coupling. Here the very, very important term, that electromagnetic coupling. Electromagnetic coupling with the driven elements, which is in the proximate with the parasitic element, is known as parasitic array. So see here, this is one element, this is another element, this is another element. Okay, so one element. So this driven element, it will excite this element, and this will excite this element. Means one element will excite the other. One element will excite the other through electromagnetic coupling. Okay, so parasitic arrays are the multi-element arrays that provide high directive gain without even feeding each element of the array. So in the up to now, in the previous cases, for each element I want to provide a supply current, but here if I provide current or supply to one element, that element makes to that elements will makes the other element to excite, and that element makes the other element to excite. That process is nothing but electromagnetic coupling. Okay, so here this is not like previous cases. In previous cases, each element is fed individually, but here if you fed one element, that element will excite the side by element due to electromagnetic coupling. Such type of arrangement is called as parasitic array. Okay, so here this is nothing but electromagnetic coupling. Okay, so and in the previous cases, excitation each element is directly provided, but in parasitic array, the arrangement supports exciting only the driven element directly, main element, and the other elements are excited parasitically. The other elements are excited parasitically. The elements which are not fed directly are known as parasitic elements. Okay, so see here in this diagram, this is our driven element. For this only we are providing supply. Okay, for this only we are providing supply. Here for this we are not providing any supply. So that's why this is called as parasitic element. This is called as parasitic element. Okay, since you are not providing any supply voltage, okay, so the remaining elements are called as parasitic. But for this one you are providing the current supply. So this is the driven element. Okay, so how it is possible? This is possible through electromagnetic token. So finally, totally, how many antennas arrays are there? The first one is broadside array. So if this is the axis of array, the maximum radiation is perpendicular to the axis of array. So the maximum radiation will be 90 degrees or 270 degrees. Second one is end-fire array. So if this is the axis of array, the maximum radiation is along the axis, 0 degrees. The third one, collinear array. Collinear array. Collinear array means here you are placing the elements one after other, one after other, one after other. So one after other. Here also the maximum radiation is perpendicular. This is the axis of array, and the maximum radiation is perpendicular. And the fourth one is collinear array. Collinear array means only one driven element will be there, and the remaining antennas get excited. This is driven element. Okay, driven element. You will provide excitation to this. If you provide excitation to this, due to electromagnetic coupling, they will excite this parasitic elements. These are parasitic elements. Parasitic elements. So totally four antennas are